Imagine waking up in 2010 and telling someone a computer will write essays, generate code, explain quantum physics, create business plans, summarize books, translate languages, and have conversations almost like a human. Most people would have laughed. Yet today, millions of people use ChatGPT, Gemini, Claude, Copilot, and other AI systems every single day. But have you ever wondered what powers these systems? How did we go from simple computers that could barely understand a sentence to AI models capable of writing software and helping scientists discover new medicines? The answer lies in one of the most important inventions in computer science: large language models, or LLMs. In this video, we will explore the complete story of LLMs. We will learn why they were created, who invented the ideas behind them, how they evolved over decades, how they actually work, why they matter today, and what the future may look like. By the end, you will understand the technology behind ChatGPT and modern AI better than most people. The dream of thinking machines. Our story begins long before ChatGPT. In 1950, a British mathematician named Alan Turing asked a revolutionary question: can machines think? At the time, computers were primitive. They occupied entire rooms and performed basic calculations. Yet, Turing believed machines could eventually exhibit intelligent behavior. To test this idea, he proposed what became known as the Turing test. The concept was simple. If a human couldn't reliably distinguish a machine from another human through conversation, the machine could be considered intelligent. This question became the foundation of artificial intelligence. However, there was a major problem. Computers didn't understand language, they only understood instructions. Every response had to be manually programmed. There was no learning, no understanding, no intelligence, just rules. Researchers knew there had to be a better way. The birth of AI. In 1956, a historic event took place: the Dartmouth Workshop. It brought together scientists who believed machines could someday simulate human intelligence. This workshop officially introduced the term artificial intelligence. The optimism was enormous. Many researchers believed human level intelligence would be achieved within a few decades. They were wrong, very wrong. Progress turned out to be much harder than expected. Language was especially difficult. Humans effortlessly understand context. For example, I went to the bank. Are we talking about a river bank or a financial bank? Humans instantly understand, but computers didn't. This challenge would take decades to solve. Early language models. Before modern AI, language systems relied heavily on rules. Engineers manually wrote instructions. If the user says this, respond with that. But language is incredibly complex. There are billions of possible sentences. No rulebook could ever cover them all. Researchers then developed statistical language models. Instead of fixed rules, computers started learning probabilities. For example, after the words "the sun rises in the next word is likely east." This was a major breakthrough. Machines began learning patterns from data. However, they still lacked deep understanding. They could only look at small portions of text at a time. They struggled with long conversations and contexts. The rise of neural networks. Scientists turned to inspiration from the human brain. They created artificial neural networks. These systems consisted of interconnected mathematical units called neurons. The idea was simple. Instead of programming intelligence, allow the machine to learn it. Neural networks improved steadily throughout the years. 1980s and 1990s. But there was another problem. Computers were not powerful enough. The internet had not yet generated enough data, and training large models was extremely expensive. The ideas were promising, but the technology wasn't ready. Researchers had to wait. The three ingredients that changed everything. Around the 2010s, three major forces came together. First, the data. The internet had produced unimaginable amounts of text, websites, books, articles, forums, documentations, research papers. And second, computing power. Powerful GPUs became available. Originally built for gaming, GPUs turned out to be perfect for AI training as well. Thousands of calculations could happen simultaneously. And third, better algorithms. Researchers discovered new methods for training neural networks. Together, these three ingredients created the perfect environment for modern AI. The stage was set. A revolution was coming. Word to vec and understanding meaning. In 2013, researchers at Google introduced a technique called word to vec. For the first time, machines began representing words as mathematical vectors. Words with similar meanings appeared close together. One famous example amazed the researchers. King minus man plus woman equals queen. The model wasn't performing magic. It had learned relationships hidden inside language. This demonstrated that machines could capture semantic meaning. It was a major step towards modern language intelligence. The Transformer Revolution. In 2017, one research paper changed everything. Published by researchers at Google, the paper was titled "Attention is All You Need." This paper introduced the Transformer Architecture. Today, nearly every major LLM is built upon this invention. ChatGPT, Gemini, Claude, Llama, Grok all rely on transformers. Why was it revolutionary? Because transformers introduced something called attention. Attention allows the model to determine which words matter the most when understanding a sentence. For example, the trophy didn't fit in the suitcase because it was too large. What was too large? The trophy, not the suitcase. Transformers became remarkably good at identifying such relationships. For the first time, machines could understand context at scale. This was the breakthrough the industry had been waiting for. GPT, BERT, and the modern era. Following the Transformer breakthrough, progress accelerated rapidly. Google introduced BERT, which dramatically improved language understanding. Then OpenAI released GPT. The name itself reveals the idea. Generative means creates text. Pre-trained means learns from vast amounts of data beforehand. And Transformer means built on the Transformer architecture. Each generation became larger and more capable. GPT-2 surprised researchers. GPT-3 shocked the industry. And then came the moment that changed everything. November 2022, OpenAI launched ChatGPT. Millions of people suddenly experienced advanced AI firsthand. Within months, generative AI became a global phenomenon. How LLMs actually work? Now let's answer the most important question. How do LLMs work? First, massive amounts of text are collected. Books, websites, research papers, documentation, public information. The text is converted into smaller pieces called tokens. The model then learns by predicting missing words. For example, the earth revolves around the dash. The correct answer is sun. The model makes billions upon billions of such predictions. Every mistake slightly adjusts its internal parameters. Eventually, it becomes extremely good at predicting language. When you ask ChatGPT a question, It isn't searching for a memorized answer. It is generating the most probable next token repeatedly until a complete response emerges. This is the core idea behind modern LLMs. Why LLMs matter today? LLMs are transforming nearly every industry: software development, education, healthcare, finance, research, customer support, content creation, legal analysis, scientific discovery, etc. They function as universal knowledge interfaces. Instead of learning complex software, people increasingly communicate through natural language. This fundamentally changes how humans interact with computers. Limitations and risks. Despite their power, LLMs are not perfect. They can hallucinate, meaning they may confidently provide incorrect information. They can inherit biases from their training data. They require enormous computational resources, and they do not truly understand the world the same way as humans do. They recognize patterns, very sophisticated patterns, but they are still patterns. Understanding these limitations is just as important as understanding their strengths. The future of LLMs. The future is likely to bring AI agents capable of completing tasks independently, multimodal systems that can understand text, images, audio, and video simultaneously, personal AI assistants tailored to each individual, scientific research acceleration, medical breakthroughs, more natural human computer interaction. We are moving from AI that simply answers questions to AI that actively helps solve problems. And this transformation is only the beginning. So, the journey from Alan Turing's question in 1950 to today's LLMs took more than 70 years. Thousands of researchers contributed, countless breakthroughs occurred, and the result is one of the most powerful technologies humanity has ever created. Large language models are not merely changing software, they are changing how humans access knowledge itself. The next chapter of this story is being written right now. And for the first time in history, billions of people can interact directly with artificial intelligence. The question is no longer whether AI will shape the future. The question is how we choose to use it. Thanks for watching.